Today we'll take a look at our SafePoint CAM200 series particulate, iodine, and noble gas monitor, which is typically used for stack or containment air monitoring applications. CANBERRA offers a modular approach to its CAM design, which supports the monitoring of particulate and iodine, and/or particulate, iodine, and noble gas in the same system. The modern open frame construction of this system takes into consideration ALARA principles with its easy access to maintenance, calibration, and sampling points. A main objective of the system design was to keep component replacement time to less than 30 minutes for key maintenance items in order to reduce potential personnel exposure. We also considered customer feedback with respect to the physical and safety challenges faced when working in cramped spaces that are common to nuclear facilities. As a result, we have designed this SafePoint monitor to provide enhanced accessibility in a low-profile, space-saving footprint. The sample flow being monitored first comes through the flow splitter, which divides the sample into a normal flow path and a standby flow path. The flow splitter is designed per ANSI N13.1 to reduce particulate loss and improve collection efficiency at the filter. All of the tubing along the sample path is stainless steel. No hoses are employed. Normally, the flow goes straight to a 3-inch shield which surrounds a detector in front of the filter paper and charcoal cartridge. The flow exits the particulate and iodine shield and then enters the 4-inch shield for noble gas, which houses a plastic scintillation detector in front of a 3-liter Marinelli chamber. Next, the flow exits through the noble gas chamber and passes through the flow controller and then through a pump to the outlet. The IR7040 intelligent rate meter powers and controls system detectors, displays and records data, and provides visual and audible alarm indication with dry relay contacts. For this application, we are employing a uniquely designed detector which allows us to offer a combined particulate and iodine channel. It uses a plastic scintillator for beta particulate and a BGO crystal for the gamma iodine measurement or detection. Where a shielded sampler is employed for the normal flow path, a differential pressure sensor is provided across the filter paper and charcoal cartridge. The sensor detects changes in the differential pressure that occur when the filter starts to clog. The sensor feeds to the rate meter, which can be set to alarm for a filter replacement based on pre-selected alarm set points. This functionality can offer several benefits. First, it may be possible to extend the time between filter changes by responding to an indication of the state of the filter rather than to a scheduled filter change interval. It also provides early notification of an emergent problem that could lead to a filter replacement in advance of the next scheduled activity. When a filter change is required, the operator can bypass the normal flow path and direct the sample through the standby flow path by simply changing the position of the valves. The standby flow path also routes the sample through a filter paper and charcoal cartridge in the FA200 filter assembly holder, so that collection of particulate and iodine samples continues during the filter change. Once the filter change is complete, the operator can redirect the sample through the normal flow path with a quick change of the valves. The entire filter change can be done in less than a minute as a single-handed operation and without turning the pump off. This design reduces the time required for filter changes over traditional designs using a threaded mechanism which requires 3-handed operation. Filter holders are designed to accommodate a lock to help prevent unnecessary tampering with the system. To maintain collection efficiency, it is necessary to maintain the sample flow at 2 SCFM. Our system uses a mass flow controller that will open up the valve and continue to maintain a constant 2 SCFM flow during the filter loading that occurs during normal use between regular filter changes. As the system starts to clog, Our system maintains constant 2 SCFM flow until it is completely clogged. At that time, it gives a low flow alarm. Our system provides a check source for the particulate iodine channel, which can be operated through the IR7040 rate meter. The rate meter provides decay-corrected readings and logs the data into the test data archive. The noble gas channel detects beta activity of the noble gas using a beta plastic scintillator detector. As a result, gamma background subtraction is not necessary. The MDN series detectors use LED gain stabilization and also include optical test functionality to verify detector operation without using a radiological source. The system includes a radiological check source. However, that can be operated manually or automatically through the IR7040 rate meter. Two three-way valves are provided before and after the noble gas chamber. These can be used for manual purge or primary calibration. The system also includes a vacuum pressure transducer that constantly measures the pressure inside the chamber and dynamically compensates the concentration value. A bypass valve is also available to bypass the noble gas chamber when maintenance is being conducted. A sample grab gas access point is available after the sample exits the noble gas chamber, providing easy access to collect a gas sample for laboratory analysis. This port can also be used to continue noble gas measurement with a temporary external detector while the noble gas chamber is being maintained. After passing through the flow controller, the sample flow continues through the pump. Our pump is an oilless carbon vane pump that is designed with a 20,000 hour MTBF. This provides 3 times more operating hours before maintenance and offers quieter operation than traditional carbon vane pumps. This pump also has a built-in pressure relief valve which allows it to run dead-headed without damaging the carbon vanes or motor. When maintenance is due, you simply check the carbon vanes and pump filter for wear and tear and replace if needed. The pump is mounted in a way that it can be easily removed and serviced. An easy disconnect plug provides power to the pump, and pipe fittings leading to the pump are constructed with flexible tubing, which allows for easy removal without disassembling the tubing at multiple locations. The flexible tubing also provides vibration isolation. If desired, dual pumps for redundant functionality are available as an option. All detector and sample process inputs are fed into the IR7040 intelligent rate meter. Each input is configured as a virtual channel for display, and each virtual channel has the capability to provide high and low alarms, which can be tied to visual and audible enunciation. The IR7040 also provides dry contact safety rated relays and digital outputs for remote enunciation. The rate meter has an internal memory which archives data being generated as the system operates and stores the data in different bins to simplify its recovery. This data can be easily viewed on screen or can be downloaded onto a USB stick in Excel format. The IR7040 also has a built-in pulsar that can be used for self-test of the rate meter on the test bench.